So the question is asking, is EO, so the stretch from here to O, which is out here, is this parallel to AP, right? AP is down here. So we don't know yet. It looks like that as if it is, but they're basically wondering, do you know, have you taken this course, right? Do you know those four things that are always true, right? If lines are parallel, but you only need to show that one of them is true. One of those four is true, you're done. You don't need to prove all the other yet, the other three that remain. It's just assumed, okay, as soon as one is proven or determined, then the rest it follows, okay? I think I will just add that to the notes because this is always a challenging concept. Um, you need to show to find a pair you have a name for. And the ones that I'm talking about is alternate exterior, alternate interior, corresponding, and consecutive interior. If you can find these any one of these in that diagram, then you're done, right? So again, I always name them in this order. I try to, because the first three here have to be congruent. Consecutive interior, that pair has to add up to 180. Okay, so that there you have to watch out for that. Okay, so let's start. There are a number of transversals crossing through these two lines that we're looking at. So let's focus on one transversal at a time. So this is the transversal that we're looking at now. So we can call this T1, we can call this T2, and this is T3. So our three transversals there. Okay, and we're going to focus on this one right now. Right now, as it stands, we do know what these two measures are, but we don't have a name for them. They kind of look like they're corresponding, but we really don't know. Okay. Um, One thing that I would encourage you to do is use the vertically opposite property, right? Vertically opposite means that, right, we know without doing any calculation that these two will be the same and these two will be the same also. The C is kind of in the way, but we know that this is 102 as well, this angle right here. Okay, and I know we normally don't use these two, but I actually have a name for them. Those two are called consecutive interior, right? They don't touch, but they're on the same side. They're both on the inside and on the same side of the transversal. So these are consecutive interior. And look at that. You can tell that they add up to 180. Okay, so the first thing that tells me that these two lines are parallel would be that consecutive interior angles are supplementary. Okay, you would be done at this point, right? You're done. You've now proven, like, it doesn't matter what happens down here. There's other transversals, but you've basically just looked at that transversal, which cuts through the two lines that we're looking at, and you're done. Okay, as simple as that. Let's focus on this one here. This would be looking at transversal 1, right? If we looked at transversal 2, and we're going to use that transversal to determine whether or not these two segments are parallel, all you need to do is look at the known angles, and you can tell right away that you have a name for them, right? Alternate interior angles are congruent. What did I do here? Equal sign with that, right? Done. Transversal number 3, we're looking at this one here. There are two angles there that we know the measure of, and we actually have a name for them. These two are called corresponding, right? These angles correspond. So you would say corresponding angles are congruent. And I will just under this say that therefore EO is parallel to AP. You could use either one of these arguments, and you could have extended these parallel lines and made a bunch of more transversals that crisscross it all along. They will all conclude the same thing, because once lines are parallel, it's not like they're going to start changing their slopes down the road. They stay parallel no matter where you cross them. You will always come up with that conclusion, right? You have to say that they're parallel no matter what, because they're straight lines. Okay, and let me just add with a different color. I tell my students, fill in with as many numbers as you can right away. Fill that diagram up, so then you have more options, right? So I like the vertically opposite property, right? So this is 49, therefore this will be 49. This is 49, therefore this will be 49 up here. And what do you know now? These are alternate exterior angles. This pair, right, if this is these two are alternate exteriors, so they're also the same, which is what we're expecting anyways. So you could have also, for transversal 2, come up with that conclusion if you show that work. Okay, so just keep that in mind. And that, I just wanted to add this to your notes so you have more. Oh, I forgot to wear my mask, sorry. Okay, so there's somebody else in the room, so that's all I'm going to say to this. I will just add one more thing that's going to act as a warm-up for today. And this is, so I'm going to add that just below this. Okay, so here you go. Copy this diagram. So you have 2x, x minus 2, 2x minus 3. So it's triangle ABC, and they want you to calculate the values of all angles. And then I'm going to ask you to dig through your pile of handouts. And we're going to go through some of those examples there. Somebody joined, I think at least one person joined after I took attendance. Can you just type here? And then I'll mark you as I can tell. who joins when. Marcus, did you join by any chance? Yeah, I got you, Marcus. Sorry, I was just trying to. Okay, Danielle, and one more person joined. You can see here. Okay, Lance. Okay, let's calculate this. So they want the values of every single angle here, and apparently, right there, they don't give you an angle at first. So these types of questions, they're gonna pop up even with the parallel lines, where they're testing your knowledge of certain properties. Okay, so what do we know about all angles in a triangle, right? Sum of angles in a triangle is always equal to 180. You know that. So sum of all angles would mean you have to add up all of these angles. So we'll go 2x plus x minus 2, right? Plus 2x minus 3. And that is supposed to add up to 180 degrees. And keep in mind that all of these are technically degrees, right? It's just stated as expressions in terms of x, okay? So because it's always adding, you can get rid of the brackets, right? If you had negatives in front, then it would change the sign inside the bracket. In this case, it doesn't. 180 degrees. So combine your like terms, right? So all your x's here, 5x, and you've got minus 5 is equal to 180. 5x is equal to 180 plus 5. 5x is equal to 185. Divide both sides by 5. You get 37. 37 degrees, that is. So you haven't yet found the values of all angles. You've just found what x represents. Now that you know what x is, you can always just go back and just plug it in to every single one of these expressions and find your angle. So angle A would be 2 times x, which is 74 degrees. Right? Angle B is 2 times 37 minus 3, so that's 71 degrees. And angle C would be 37 minus 2, which is 39 degrees. Ah, sorry, 35, I know. I caught it. So this is the type of question when you have something like this, your first go-to is, okay, what do I know about these angles that have an x in them? What relates them? Well, it's this property that relates them. Then do what you know needs to be done. In this case, we need to add them all. And then you come up with the unknown. It could be y, it could be z, whatever. And once you've determined, they could just ask you to find the value of x, at which point you would be done at 37 degrees. But if they ask you for the value of the actual angle, you have to go back and plug it in and find it that way. Okay? Okay. That's that for the warm up. Now I'm going to ask you to go through your stack and take out this handout right here. Okay? You should have that in the stack that was stapled that you got last week and Monday, right? So you should be able to get that out because we're going to work through that. And this will perhaps answer some of the questions you had on the worksheet that I assigned. You got to the back, you're like, what? I don't know what to do here. This will answer it. Okay, so sometimes I'm giving you work that you may not be 100% sure how to do yet. And then we just wait until I keep going a little bit more, and then you'll probably be able to do it down the road. So go find this. If you don't have it, let me know like right now so I can post it, but I'm assuming everybody has this. Okay, so I made this handout because the textbook doesn't have enough examples or even questions to work through. So I'm going to use this as a worksheet as well as note taking. Okay, so it's going to be both before we move on to the next section. Okay, so here is one question that tells us that the lines are these two segments, these two lines are parallel. So that's very important to us because it tells us there are 4 things that we know are true now. Okay, 4 things are true: that alternate exterior, interior, and corresponding angles will be congruent, and that consecutive interior angles will be supplementary. Meaning, if I can use these 2 pens, consecutive interior would be these 2 here. They should add up to 180, and so would these 2. Okay, this pair adds up to 180. This pair adds up to 180. Okay, so, and this is one of those where you have no angle given. So you need to look at a property. Okay, what do we know about these 2 angles? The ones that have the variable that we're trying to solve for. Forget about A, B, C, and D because that's what they're asking you to solve for. We need to first figure out what X is. Okay, so determine X first. Okay, we know that 9x plus 32 and 11x plus 8 are what? What kind of angle? What name do we have for these? Corresponding, right? Anyways, I'll try it down here. Are corresponding angles. Okay. So what do we know about corresponding? Therefore, 9x plus 32 should be exactly the same as 11x plus 8 because this represents one angle and this represents the other angle. and we know that they're equal in value. So it's a little different, right? Compared to the triangle, we were adding them all up. Now we're making them equal to each other. You can bring I would bring all x's on this side and all the numbers to the other side. So 9x minus 11x is equal to 8 minus 32. So you have minus 2x is equal to minus 24. Divide both sides by negative 2. X is equal to 12. And that's degrees, okay? So I will just say, I guess you already did say, like this statement here, corresponding angles are congruent. So what we're going to do here is, to make this easier, I'm going to call this, we have A, B, C, D. I'm going to call this E, right? And I'm going to call this F, just so it's an easier way to refer to these two. So on the side here, I'm going to come up with angle E. So angle E is 9 times x, which is 12, plus 32. And that's 140 degrees. Okay. Angle F, I'm going to get rid of that one next. That's 11 times 12 plus 8, which, lo and behold, it gives us 140 as well. How can that be? Well, they're corresponding, so we expected that to be the case. Okay. And now we can find everything else. Right? I'm going to find angle A. A is over here, which is vertically opposite to that one. Right? So I know that it's going to be the same as E. Vertically opposite to angle E. Okay. Next, I'm going to find D. Why not B? We should find B, right? Just go A and B. So you kind of like, you go from here to here by using the vertically opposite property. Then you can go from here to here by using the corresponding angle property. Okay, so B is 140. So you can use corresponds to angle A. But somebody is probably thinking, wait a minute, isn't it vertically opposite to F? Yes, it is. So if you wanted to use that, go for it, okay? Now we're going to find C, which is, it's a straight line here, right? There's a straight line, it's being cut by this side, so we know that these add up to 180. So C is going to be 180 minus 140, which is 40. That's all I would ask you to do there. You don't have to say straight line. I can tell you know what you're doing there. And last but not least, D. Angle D, because I'm here now. I'm literally I started here, I went there, vertically opposite. I went here, corresponding. I went here by using the straight line property. And now I'm going to go to D using corresponding again. So that would be 40 corresponds to angle C. And I've justified. I didn't ask for it, but I did it anyways because then you know how to do it, how to think through it. So knowing that, knowing what I've just done and how I've used the properties, okay, we are going to go to the bottom of this page. So if this is question 1, we just did question 2, wait for a bit, and then go to 3 down here. Finding the 2 missing angles. So find the angles of x and y, and then I want you to determine the measures of all angles there. You know what? I'm just going to say this. Just find the at the bottom here, scratch this, and just focus on finding x and y. Okay, so do this now. So work on this, on these 2 questions now, okay? See how you do with that. If you want to do it on loose leaf on the side, and then wait for me to do the clean copy, that's fine, but you have to try it now, okay? So go down to question 3, and we're going to focus on this one here. You cannot do this unless we're assuming that these 2 lines are parallel, okay? So first of all, that I would make sure that's there on a test or whatever, or if not, you can just assume that, or else there's no way you can do that. Okay, so these 2 angles have a name. We know that these 2 are consecutive, a consecutive interior. And we know that they add up to 180 degrees. Okay, just those 2. So 5x plus 26, right, plus the other angle, which is 3x minus 46, is equal to 180. So see how it's different? It's not going to be the same every time. So you have to just know what the properties are. Because there's a plus in there, we can just rewrite it without the brackets. We combine like terms, so we have 5x, 26 and minus 46 is negative 20. It's equal to 180. 5x, you bring the 20 over, it's adding. That's 200 degrees. Divide both by 5. X is equal to 20. Wait. I made a mistake, didn't I? 8. It's 8x. 5 and 3. 5 and 3. That's 8x. So change this to 8. And everything to 8 here. So that's 25 degrees. So we found x, and that's all we needed to do. I shortened it because at this point, filling out the angles, it's not that difficult, right? Once you find x, you go back, plug it in, and then use vertically opposite and straight lines to fill in the rest, corresponding angles, so forth. All right. Now this one here, okay, this is different. I don't know if you've tried it, you're like, wait a minute, I know what these 2 are called, but there's an x and a y. Well, that won't work, it won't help you. So what you have to do here on top of everything else, find 2 that have the same variable and then identify what name you have for them. So I look at, there's a y variable there, there's a y variable here, that's the name I'm after, okay? These 2 are alternate exterior, and we know that they are congruent, okay? Alternate exterior angles are congruent. So we're going to go 2y plus 10 is equal to 4y minus 14. Bring the y's over here, you get 2y minus 4y. The 10 comes over on this side, like that. This would be negative 6y is equal to negative 24. Divide both sides by negative 6. Y is equal to 4 degrees. Okay? So there you found y. And no, it's the one that's, 1 second. Yeah, that one. Yeah. Yeah. Okay. All right. No problem. Next, so we kind of scratch these now, right? In the meantime, and just focus on the ones that have the like terms, right? So x and x, what name do we have for these? Right? These would be a straight line, right? We know that these two add up to 180. So 11x plus 8 plus 9x plus 32 is equal to 180. And we'll just say that's a straight line. Straight angle, right? Anthony, did you find a mistake? Oh, yes. Thank you. Sorry, guys. I hope you caught it before you wrote it down. 2y minus 4y is negative 2y. So you have to divide everything by negative 2, giving you 12. Thank you. Okay. And now it's on camera. It's on record. Anyways, so this is true, right? Property. So 11 and 9, that's 20x. 8 and 32, that's 40. And that's 180. Bring the 40 over to the other side. Divide both sides by 20. X is equal to 7 degrees. And there you have it. So now, okay, I want you to, we're going to keep going with our notes, but now you can go back to that handout on the second page. Remember these ones? Solve for x, starting question 19. Okay, so homework here, try solve for x. Worksheet. Okay. So you go back to that parallel lines and transversals worksheet. I posted the answer key to that as well. And then you try those questions. As well as the ones I'm going to do now, some of them are going to help you do this worksheet again and do it better, or now being able to do it whereas you couldn't do it before. Okay. So this handout is not to be chucked or, I'm done with it, we're moving on. It's like, go back and do it after today, okay? All right. We're going to go back to question 2 in a sense, okay? And give that one a try. All right. So find this, the middle section here. And this is a parallelogram. I don't know if you remember what a parallelogram is, but right, you have two pairs of sides that are parallel to each other, hence the name parallelogram. So what is confusing about this is that a line that at first, right, a line that at first seems to be parallel is also a transversal to the other parallel lines. So it's a bit confusing at times how that goes. What you need to remember is if it's a parallelogram, is that you can jump this way and this way. Okay, you can use the corresponding and alternate exterior interior going this way and this way, any which way around the shape because everything is parallel. Every opposite side is parallel to you, so you get to jump that way if you know the property, and then jump sideways and back down. Like it works that way only with parallelograms, and that's denoted by the marking, right? It's a parallelogram. Okay. So they want the values of A, B, C, and D. No, they're not asking you to explain here, but I will explain and justify, okay, how I came up with that. Now, we start with 115, that's very important, right? And then you try to find an angle that corresponds to it, an angle that's alternate, interior to it, exterior to it, maybe, right? Some vertically opposite, you can do whatever you want. I see that this one, if I were to jump to that one, how are these two related? They are corresponding, okay? So what do we know when two lines are parallel and you're going along the transversal, right? We know that these two will be corresponding. Okay, so A is 115 degrees, corresponding angles. That's it, corresponding angles. So you got that out of the way. So you can actually write down 115 here. Makes it a little easier. So I did this one first because sometimes some students will start a different way. So I just tell myself this is the first thing I've done. Now B, I like to use vertically opposite whenever possible, okay? Sometimes I don't, just to prove a point that you can do it a different way. But B is 115 and you just say vertically opposite to A. Done. So you're done here. And in this particular case, you can continue like that the properties continue because these two are parallel lines as well. So how are A and C connected? Do we have a name for A and C? And allow me to do something here. You almost have to be able to do this because that's how we've seen every example so far. It's like, what are these two? They're consecutive interior because these two lines are parallel and there's a transversal connecting them. So I'm going to go back to normal, right, and just say that that's the third angle I'm going to find, and it's going to be 180 minus 115, right, and that would be 65, and that's because it's consecutive. Consecutive interior to angle A. And I'm just going to say that because then it's easier to go back later. It's like, how did I do this, right? So I went from here to there, and then I went to here. And I noticed that these two, right, were again the parallel lines, and this acts as a transversal now. C and D, how are they related? there's a name for the two, and that's alternate interior. So D is going to be 65 because it's alternate interior to angle C. And we can assume that they're equal because of the parallel lines that appear, right? They are between two parallel lines, so then you can always assume that they're the same, okay? And so that's how you do a question like this. Okay, let's flip over to the back side. And this goes a little, this takes it up a notch, okay? So this takes everything into consideration, everything you've learned, or the properties that you know about different shapes, okay? I'm thinking if I should, one second, okay? Just okay. I'm gonna ask you to copy some notes. We're gonna leave this for now. We're gonna come back to it, okay? I'm first gonna get you to write a few things down about triangles. So here we go. Take your notes back to loose leaf. And just a couple things about triangles before we continue with our, and there's a homework and everything already. And notice that the worksheet comes back, okay? So write down the title exactly as it is, 2.3, properties of triangles, and write down this chart, and I will explain it a little bit as well, okay? So I'm guessing it'll take you a couple minutes to do this, so write this down. I already pre-made this so that you can just copy it. Okay, so um, properties of triangles. So this is just a review, right? You have the three main types, right? Scalene, isosceles, equilateral. Scalene is where you have all different side lengths and all sides are different and therefore or all angles are different as well and vice versa. If all angles are different, you know all sides are going to be different. It's important for trig, which is coming up too, right? Longest side, remember, is always across the largest angle and vice versa. Shortest side across the smallest angle, okay? When you have an isosceles, two equal sides and two equal angles. And notice that if the sides are equal, then the angles across those two sides are going to be equal as well. So I drew it like this, where these two sides are the same. And then you know the angles across from them are the same as well. So if you wanted to find angles A or B, right, you would take, let's say you want to find A, which is the same as B, right? You would go 180 minus C divided by 2, making sure this is in brackets. Some students forget the basic bed mass rules, right? You first do this and then you divide by 2, which is also the same as B, okay? If you want to find C and you're given A, or B for that matter, it's 180 minus 2 times the value of A because they're the same, right? Equilateral, nothing really to say there, but it's always 60 degrees. The interior angle is always 60, no matter the size of the triangle, okay? It's always 60. So important to remember that. And there's a concept here. This is related to the isosceles triangle, okay? So write this down as well. An isosceles trapezoid, it has the two sides, right? Has these two being the same. This one, not necessarily, but if the markings are there, then you know it is, okay? And you notice that they're parallel. These two lines are parallel. Okay, so now we're going to go back to the handout we're working on, okay? Okay, so we're gonna do this one up here first. Okay, so here the notation of the angles is gonna throw you off a little bit. Okay, so given that ABC is 35 degrees, angle it is, right? So ABC, right? Emphasizing that B is in the middle, 35 goes here. That's how they refer to that angle. And then angle EAD, that's EAD, that's the angle at the top here, is 75 degrees. Okay, so now they're asking us for a whole bunch of angles here. The easiest one to find is angle C here. So we're going to go ahead and do that. So that would be 180 minus 75 minus 35, because it's a triangle, right? So that'd be 70 degrees. So you have 70 degrees, and that's because sum of a triangle, of angles on a triangle, is always equal to 180. So you can go ahead and fill that in. I'm going to use a different color. You have 70 there, and it's not drawn to scale, obviously, okay? But now, what other angle can I find? It's asking for angle ADE, so ADE, this one right here. How would I find what that is? Well, now you got to use your parallel lines, right? We know that these two are corresponding angles. Doesn't look like it, but this is your transversal, and these are your two parallel lines here. So these are 35 and 35. Okay, this came over there. And so we can say 35 degrees, and the explanation would be corresponds to B. Okay. And then there's CED, so it's C, E, and D. This angle right here. We know that these are consecutive interior and that they add up to 180. So we'll just say that this is 110 consecutive interior angles. You could say 2C if you wanted to, but notice that they're not the same. They add up to 180. So we can put down 110, right? Then you're not worrying about that anymore. ADB, ADB, that's actually a straight line here. So that angle is 180 degrees. Straight line. Weird, right? But it is. It is a straight line segment there. And AED, AED, that's this one right here. Two choices there. You can use the straight line property here, knowing that that's going to be 70, so that they add up to 180. Or you could use the corresponding angle property. I'm going to use that one. Corresponds to, in this case, because C has nothing around it, you can just refer to it as angle C, like that. Oh, something in the chat. Oh, okay, that was old already. Okay. Folks, I want to do one more before we go. I know it's almost time, but you're all at home, and then there's a long weekend, okay? Just one more question. And then I want you to, if you haven't done that worksheet yet, the parallel lines, the worksheet I assigned yesterday, the key is up there. I want you to try that one. And after this example that I'm going to do here, I want you to try this worksheet. Go look this up. Section 2.2, properties of parallel lines. You don't have to do it on loose leaf. You can do it right on here. Okay, so look at the screen and go find this worksheet right here. It's in your package. Okay, so we're almost done. I'm not going to do the very last one today, but I'm going to do this one. Okay, you should see triangles. You should see triangles, a bunch of triangles in this mix here. Thank you very much. Yeah. Oh, sure. Okay. You know what? That's good. Next Thursday is fine. Yeah. Yeah. Thank you so much. Okay. So where was I here? Okay. How would you even get started here with this, something like this? It's very, very busy. What I want you to do here is highlight the parallel lines, right? So this is parallel to this. Okay, that's very important to remember. And there's there's a transversal here, there's a transversal there, and there's another transversal there. So these are parallel lines and they're connected by 3 different transversals. So you only stick to one transversal, okay? So let's see what we do if we follow this one right here. If we follow this transversal here, between these 2 parallel lines, yes, yeah, this is an alternate interior angle. These 2 are alternate interior. So this is 53. So I'm going to go angle C is 53. It's alternate interior. So I did that first. Okay. Then once you have C, you can actually find F because there's a triangle in here. And out of the 3 angles, you already know 2. Okay, so the second one I'm going to find is angle F, which is 180 minus 53 minus 44. 83 degrees. And that sum of triangles 180. That's the explanation there. If you did this work, I would have been fine. I would like you to say sum of 180 though. Once you know F, you have a vertically opposite angle right across from it. So angle E is the same thing as 83, vertically opposite. So now you know that this is 83, this is 83, and you have a straight line here, so you could use this straight line to come up with D, right? Or you could use this straight line here to come up with D. Either way, you're going to get the same thing. So for angle D is 180 minus 83. And that is 97. Straight. Sorry guys, I'm gonna try to rush and then it's gonna be on the video at least, so you can look at it tomorrow. Okay. So that's 97. Now that you have this, you can easily find A because there's a triangle here as well. Okay. So angle A is going to be 180 minus 53 minus 83. And that is going to be 44. Sum of triangle is 180. And then the last one is B here. And you should also recognize that there's a triangle here, of which you know 38, 97, and you can find that one right there. And then we're done. 180 minus 38 minus 97. That's 45 degrees. Sum of triangles 180. Okay, that's it. Have a good long weekend. Sorry about that. It's going to be recorded, so you can look at it again if it went a bit too fast. But do that worksheet, those two worksheets, okay? Have a good long weekend.